Okay, these integrals are going to require trig identities. Okay, so none of them, if you look at them, are in the form that we've previously talked about in order to be able to do the reverse chain, or as we were calling it, IOD. Okay, remember, for each of those, to be able to just integrate those by looking at them, they need to have a function and its derivative somewhere within that expression. Okay, each of these require a trig identity. Okay, because they as they stand there, they do not exist in the formula booklet either. Remember, you've got lots of ones in the formula booklet, but those are not in the formula booklet as they are. So what we need to be able to do is use the trig identities to rewrite them so that they are in the formula booklet. And these are ones that you're just going to have to remember that they require a trig identity. Okay, so if we think about in the integral of tan squared, so obviously tan squared is not in the formula booklet. However, it's related to something that is. So have a little think about what do we know the integral of that's related to tan squared? Okay, I'm hoping you're thinking of sec squared. So we know the integral of sec squared is in the formula booklet. So if we consider using the identity tan squared x plus 1 equals sec squared x. So that's the identity that we need to use. Okay, so instead of tan squared plus 1 equals sec squared, I'm going to write the integral of tan squared as sec squared x. Oops. Sec squared x minus 1. So I've just rearranged the identity to make tan squared the subject. The integral of tan squared, we know, is tan x, okay? And that's in the formula booklet. And we also know the integral of 1 is x. So we've got tan x minus x plus Colin. Okay, for cot squared, well, again, cot squared is not in the formula booklet, but it's related to something that is. Okay, this one is related to cosec squared, and the integral of cosec squared is negative cot. So we know the other Pythagorean identity, we know that is cot squared plus 1 equals cosec squared. So like I did with the other one, we're going to say that's equal to the integral of cosec squared x minus 1. Okay, from your formula booklet, we know that the integral of cosec squared x is negative cot x. And then again, we know that x minus 1 goes to x. And then we have plus Colin. Okay, so those two are using the Pythagorean identities. Okay, for the integral of sine squared and cos squared, very similar method. Okay, if you think about trig identities that involve sine squared. So I suspect you're probably all thinking sine squared plus cos squared equals 1, which is true. Okay, but that doesn't help us because we also don't know how to integrate cos squared. So that identity is not going to help us. But there is another one. Can you think what it is? Well, we know that cos 2x is 1 minus 2 sine squared x. So if we rearrange that, we can say that that's the same as, so sine squared, so imagine adding 2 sine squared or moving it to the left and the other one to the right. We'll get 1 minus cos 2x, and then that's halved. Divide by 2. Okay, so now we can integrate both of those. Integral of a half is a half x, a half x. Integral of cos is sine, so it's going to be minus sine 2x. But then we've got to divide by the derivative of the internal function, which is a 2, so that's going to be over 4, because it's already over 2 plus Colin. Okay, so that's how to integrate sine squared. You're just going to have to sort of remember. You don't obviously need to remember what the integral is, but remember that we had to use the double angle formula for cos. For cos squared, well, we're going to use the other one. We're going to use the other double angle formula for cos. So cos 2x is also 2 cos squared x minus 1. So again, if we rearrange that to make cos squared the subject, so if we add the 1, and then we need to divide everything by 2, it'll look like that. So it's really similar to sine squared. Very similar. I've forgotten my 2 there. Don't think that looked right. I'll just put my 2x double angle formula. So if we integrate half cos 2x, again we're going to get a quarter sine 2x, or sine 2x over 4, plus a half x plus Colin. Okay, so they are practically identical. So they both use the double angle formula for cos. Okay, it's so important that you memorise these trig identities. Absolutely crucial for so many things. Okay, and then the last one of these examples is sine 3x cos 3x. So I'm hoping that that's making you think about an identity that you know. I'm hoping it's making you think about the double angle formula for sine. So sine 2x is 2 sine x cos x. Okay, so remember there's a 2x there and a 1x there. So if there's a 3x there, then we'll need a sine 6x. But there isn't a 2, which means we need to half that. So that's what we're going to integrate. So the integral of a half sine 6x. Well, sine integrates to minus cos. But then we need to divide by the derivative of the 6x. So we'll have a minus 1/12 cos 6x plus Colin. Okay, they are the basic ones. All right, we're going to look at a couple of more complicated ones. So we just need to be thinking about for whenever you come to some that have got some complex trig, it's a bit like manipulating when we did the proof in the trig topic. It's trying to make it look less complex so that it's in one of these forms. So if we can sort of break it down into less complex trig using the identities so that we're in a position where we're comfortable with the integration. That's the aim. Okay, so here's the first one we're going to have a look at. entitled harder ones. Okay, so we've got limits for this one, so we need to integrate it and substitute a limits in. Notice that these are in radians. We're always in radians when we are using differentiation and integration of trig. We always have to be in radians. Okay, so even if you don't get the clue from the fact we're substituting values of pi in, you've got to remember that we're in radians. Okay, find the exact value of. Okay, there's probably a couple of ways of doing this. I'm just going to show you one way, that's probably the most efficient way, but it might be worth seeing if you can come up with another way. After, I'll give you a hint as to what you might do to try a different version. The easiest thing to do, well, you've got a sin x cos x on the bottom, and again you should be thinking double angle formula, sin x cos x. So if I'm just going to put limits in because we're not ready to integrate yet. So that's the same as 1 over sin x cos x squared. That's the same. Now 2 sin x cos x is sin 2x. So 1 sin x cos x is a half sin 2x. Okay, and you'll see why I want it to be like this in a second. Obviously, the more you do these, the quicker you'll see. You'll see how to write it. So that's the same as if I square that bottom bit. A half squared is a quarter. And then I've got sine squared 2x. If I do 1 divided by a quarter, so I'm getting there, I'm nearly there now. 1 divided by a quarter is 4. So we've got 4 over sine squared 2x. Now, 1 over sine x, we know is cosec. So the reason why I wanted it to look like that is because I know from experience, and because I've practiced it, that I know what the integral of cosec squared is. And so again, the more you do, the more instinctively you'll know what approach. So 4 over sine squared 2x is the same as 4 over cosec squared 2x. That's in the so cosec squared is in the formula booklet. So now, because we've got a bit of IOD, we've got an internal function of 2x. So I'm just going to come up here. So integral of cosec squared x is negative cot x. But then we've got an internal function of 2. So we need to divide that by the 2. So we've got 4. And then we've got negative a half cot 2x. So I'll just say that again. So cosec squared x goes to negative cot x. Because we've got an internal function, we need to also divide by the derivative of that. So that's where the half has come from. And then the 2x just follows, doesn't it? Because it's in trig. So if I just tidy that up, so 4 times minus a half is minus 2 cot 2x. And we don't need colon this time. We do need some limits. Pi on 3, pi on 6. So if we substitute them in, negative 2 cot. So 2 times pi on 3, 2/3 pi. Minus 2 cot. 2 times pi on 6 is 1/3 pi. Remember, you haven't got cot on your calculator. But you do have tan, so that's going to be the same as minus 2 over tan 2 pi on 3. And then we've got minus minus, so plus 2 over tan pi on 3. Okay, and then if you put that in your calculator, it should come out as 4 root 3 over 3. Okay, so that's the final answer there. Now there are other approaches, like I said. So an alternative, I'm not going to show you the whole thing, but maybe you could try it, is you could write that as 1 over sine squared times 1 over cos squared, and then 1 over sine squared is cosec squared, and 1 over cos squared is sec squared. And then see if you can do something with that. Okay, using the Pythagorean identities to get into a point where you can integrate. But you should find, if it works, you should still end up with the same one. Okay. Let's just have a look at this one. So find the integral. This is probably a bit easier. So hopefully you're thinking expand the brackets. So that's what I'm going to do. So 1 plus cos x all squared is 1 plus 2 cos x plus cos squared x over sine squared x. Okay, we've got one denominator, so we can split that up. We can say that's the same as 1 over sine squared plus 2 cos x over sine squared plus cos squared x over sine squared x. Okay, if we keep going, 1 over sine is cosec, so that's cosec squared x, and we know what that is, it's in the formula booklet. Now cos x over sine squared, we've seen this before, that's the same as cos over sine, which is cot, times by 1 over sine, which is cosec, and that's in the formula booklet. And then cos squared over sine squared is cot squared, which is not in the booklet, but I showed you or talked to you how to do that at the start of this video. So we can't integrate just yet because that third term is not ready to go. So notice I've still got my squiggle and my dx because I've not integrated yet. So cot squared, remember, is not in the formula booklet, but we can write that as cosec squared x minus 1 using the identity cot squared x plus 1 equals cosec squared x. Okay, now we've got 2 lots of cosec squared, so let's tidy that up. So we've got 2 cosec squared x plus 2 cot x cosec x minus 1. Okay, and that's all good to go now. So the integral of cosec squared is negative cot, so that's negative 2 cot x. The integral of cot x cosec squared is cot x cosec is negative cosec, so we've got minus 2 cosec x. That's in the formula booklet. And then the integral of minus 1 is minus x. And then we just need Colin. Okay, so you can see it's just a matter of expanding, manipulating, fiddling around with it, using the identities The more you know the identities and the more you practice, the quicker you will spot which direction to go in. Okay, so just keep practicing and plugging away at it. Okay.